Jenny? Or?
Good morning, everyone. Today we give another lecture about ROS. ROS is our communication platform which we use to control our robots. It's mandatory by our product owner. He says you have to use ROS because the first group also used ROS, and it's a modular system, and yeah, it was mandatory for him. So we're going to use ROS. Today I want to tell what is ROS, how the communication in ROS will work, then how our communication with our robots works, so an example. We should do the demo, but yeah, the robot didn't work this morning, so technical demo will not be. And then questions or suggestions or some feedback. First, what is ROS? ROS stands for Robotics Operating System. It's a platform where everyone builds software to drive with robots or robots in fabrics or that kind of way. Also self-driving cars, drones, all kinds of robots can be controlled by ROS. ROS is open source, so yeah, that means everyone is working on the progress is going very quick. You can suggest new libraries. You can very easily create your own tutorial, and that means there are a lot of tutorials about ROS, and also good tutorials, good information. It's modular, so you can build on each product you created, and each modular system can communicate with the previous one. So this also about the communication. Another part I meant is that you can create multiple nodes. The first thing you have to do is you create a ROS server. So you start up a server. It can be on your own PC or on Windows Server or Windows Server. Then you create nodes, which are your programs. So you can create a node which that Willy drives. So our nodes, we have one node which is the Arduino. Then you have to do the registration to the server, and with another node you can, for example, create a control that reads the input of a controller, and then those two nodes can communicate with each other. And you can create a third node to read the data and create some statistics. Yes. So you have nodes, which are your program, you have a server, and that's your own thing. Then the communication with Willy. We have an Arduino placed on the wheelchair, which is always on there. Then we have a PC and a server. So first, to let Willy drive, there's a listener on which is called CMDVAL. The Arduino subscribes on this listener, and every comment which will be published on the CMDVAL executes the Arduino, and the server is going to publish comments on the CMDVAL. So it's not like in the last techniques were about intervals, so go check every 1 minute or every second to the server if there's a new thing. Now the Arduino will get a message if there's a new comment placed by the server. Then the Arduino gives feedback. The Arduino has also a node, so it can also publish on a new listener. And the server is going to subscribe on this little node, so we get feedback about what the Arduino or what the wheelchair is going to do. Then you can create a third one, which is your odometry, which stands for it's the feedback from the wheel, but then calculated where you are. So the wheelchair, the feedback is like I'm moving 10 x's forward, and the server is going to create a map of it and calculates where it is. And you, as a PC, can then subscribe on this odom and read or publish on the map where you are. I would do also a technical demo where I can show you all the things, but that's like I said, did not work this morning. So I want to give you a code example for the software developers on ROS. this is an example of how you do the communication with ROS. As like I said, you listen to the cmd_val command. It's going to execute the message and set the values in your local variables. Then you have a new publisher, which is the wheel encoder, and on this wheel encoder you're going to publish the data you read out of your encoders. Like the values read, you're going to publish it to the motor controller. So all the data you received by the cmd_val, you're going to write it with a serial port to your motor controller. Then you read the ticks of your encoder and publish it to the wheel encoder. So it's very small Arduino code. It does two things. It reads the cmd_val and lets the robot drive. And the second thing is give the feedback to the server, what have I done. So that's the communication in Willy, like we are using it. Is everything clear about that? Communication? Yeah, like I said, it's a little bit shorter because of, I would give a technical demo how you start across, how you gonna execute everything, but that part wasn't working this morning. So, are there any questions, suggestions? Notes?
You talk with the server?
Yes.
So if you don't have internet, there is no moving Willy.
For now, the server is your PC, and your server is.
But you have another PC as well. Two PCs.
For now, those two are the same PC.
Okay.
But in future, it will be like you have a server, which is, for example, placed on Willy, and your PC external, where you can read the data.
Yeah. Okay.
But for now, those two parts is one laptop. But we want to replace it because you don't want to have the laptop on your Willy, on your wheelchair while Willy is while Willy is driving through the city. You want to keep the little
And everything gets programmed on the Arduino?
For now, everything which was programmed is on Arduino.
What happens when you don't have enough space? Because the Arduino is kind of...
Yeah, that's the part. Yeah, that's a good point. But
because you're using the Arduino structure, I don't see any pointers.
the Arduino does two things. He listens and he communicates and he gives feedback.
No.
But that's everything he does. And he doesn't do more in the future because the server is calculating all the data and is calculating its route. So the Arduino, this code will be the same. Arduino don't get to do more.
So you don't program anything else on the Arduino except for the movement of the engine?
No,
okay.
nothing. Because this is working. The engine is working, the controlling is working. And we have to do the logic in C++ and create a new ROS node. So we program ROS
that
nodes.
happens on the server?
And that happens on the server, yes. So nothing code in Arduino. And maybe some small adjustments for later on, but no logic in the Arduino. No logic. Just execute and just get feedback.
In the future?
In the
But
future,
there will be more functionalities than just the path planning.
that will also calculate on the server. Because Arduino has to do two things, execute and give feedback. And the server is calculating everything.
Yeah, but driving is not the only functionality, right?
No, for later on the connects will be another thing. So it's going to give some obstacle detection, but also this obstacle, the connect will not be connected to the Arduino, but will be connected to the PC on the server, and it's not going through the Arduino. Arduino is.
How does it get sent to the server then? Because the listening and the sending happens through the.
With the connect, you mean?
Oh yeah, you have to connect on the wheelchair. How does that information get sent through the server?
If you have to connect on the server,
The
then the connect will have another will be connected to the server and will be a new listener.
So the server is always going to be a computer on the wheelchair.
Yes, exactly. So the server is the base of Willy, the base. So he's connecting to the Arduino, he's connecting to other hardware. So the Arduino for now, the connect later on maybe some GPS or other location system. So the Arduino will never have logic, and that's very good because Arduino is not good for logic.
What about human interaction? It's not for now, but in the future it will.
Mm-hmm.
How do you think that will fit in this whole picture?
Good question. I think it's very easy with ROS because then you have some screen. For the human interaction you have some screen on the robot and some interaction, he talks and etc. And also this human interaction can control the Arduino or control the wheelchair because of the system with listeners and subscribers. He just is another listener and can also communicate and listens to the CNDVL. So the human interaction will also be a connection between the server and the tablet, or what will it be?
Okay, but then you need more logic in the Arduino.
No, because Arduino has one thing to do: execute and give feedback. And the logic, because the human interaction will be on a screen like, say, tablets, iPads, something like that. And it can communicate with the wheelchair or read the wheelchair by the CNVL or the wheel encoder or the autometry.
Okay. Arduino has to send signals to the microphone or the screen or something.
No, because the microphone or the screen is connecting to the server, not Arduino. Arduino has to do one thing: just control and give feedback about the motor controller. Nothing more. Nothing logic.
So it's only for the motor controller?
Yeah, Arduino is only for the motor controller.
Okay.
It's connecting to the motor controller.
So it gets more functionality. It might be possible that you have multiple Arduinos as well.
If Arduino is your choice for the hardware, yeah, then it will be that. But I don't think Arduino is good for logic, and also for microphone. Yeah, I think then a Raspberry Pi, for example, is better.
Mm-hmm. That depends.
Yeah, it depends, but yeah, some suggestion.
Yeah.
Yeah. But for now, the Arduino is just connecting to the wheelchair and does nothing about logic or something like that, and it will not do.
Okay. And if there needs to be more logic on the wheelchair,
Yeah.
you probably gonna use another Arduino or a Raspberry Pi or a tablet or something like that.
Yeah, which is connected to the server and not to the Arduino.
Okay. Yeah.
The server, yeah, server is maybe not a good word, because when you talk about server, it's, yeah, you're thinking about the data center, and but for now, more servers placed on the wheelchair. It's like the computer on the wheelchair.
Right now, the Arduino is only a pass-through,
Mm-hmm.
and it only gives feedback back to the server, so it doesn't do anything more and anything less.
Well,
It's just a
and it
connection
will
between
not
the
be-
server and
No.
the motor controller.
Okay.
For now. And the rest of the human interaction is out of our scope,
Yeah.
but it's something to keep in mind.
Yeah.
Right now we're already thinking about new hardware to replace the Arduino maybe by something new. But that's, yeah, you know, for now it works, and we have to see what it does in the future. So yeah, that is a potential risk or an idea to replace it, but we're not really looking into that because we got our own project right now with our own scope.
Yeah.
So that's more important than think of new creative ideas.
Yeah. Well, I don't think it's a problem because you can't just keep the Arduino for the controlling the driving functionalities.
Yes.
And if you need more functionality, you can just add another Arduino to the.
Yeah, exactly. And that's the good point about ROS. You can just communicate or read the data from behind projects like the CNVL or the wheel encoder, and just publish on it or read from it and communicate with it. That's the cool part about ROS.
And how does it work on the server? Can you share something more about that?
Yes? I can give the demo like it should work.
Okay. Yeah. Do you have any idea why it doesn't work?
Arduino does a good start. It does not start good. No, but okay, doesn't start.
It doesn't start up.
Okay.
Because yeah, it's
Probably
something weird. First, to start up the server, just type raw score. Then-
You're not seeing anything.
Oh, sorry. Just to start the server, you just type raw score, and then your server is running. Now my server is up, and you can now view your nodes by ROS nodes list, and then you see all your current listeners and subscriber. The default is for ROS out. It's something about ROS. My screen is flickering. Yeah, for example, you can now, this is a node which you can control the robots by typing using the keys. Yeah, that's the good word. Now I can, if it's yes, you have now another new node which is called tail-up twist keyboards, which isn't the one that I can try. Ego. It's the good. It isn't the good one. Yeah, I can view the feedback about the robot. That was the cool part, but that isn't work. The server is like this. Now your server is running, and then you can start up multiple ROS nodes, and those can communicate to each other, and then you can see by this ROS node list that you have a new node, and you can echo the output, so you get real-time feedback of this is the current output. But yeah, like I said, the Arduino isn't connected, and I can't start it now.
We only had the keyboard working, but then we replaced the keyboard with a joystick.
Mm-hmm.
And then you can see the feedback of the joystick. I mean, you're pushing buttons, so that is one feedback.
Yeah.
But right now we put wheel encoders on it, so if the wheels drive, they will give feedback as well. It gives 120 ticks, 128 ticks, so that's pretty precise.
Rotation?
Rotation.
Yeah.
Per rotation, yeah, per rotation, yeah, sorry.
Oh, that's quite precise, yeah.
It's
Yeah,
like
that's
this
really-
wheel, so pretty precise.
Yeah, it's really precise. So if we're driving by keyboard or by joystick, it doesn't really matter. We can listen, we can echo the wheel encoder, so we will see the real feedback on the X axle and on the Y axle. So that means driving forward and driving to the side, for example. We will get feedback by that, and if we put calculations on that feedback, we can calculate where the robot started and where it ends.
Yep.
And that's our base for letting him drive, for example, in a square or something. That's what we're working on now. We had some technical difficulties. For now, it's the Arduino which is not working. Last week we had the wheel encoders, which one suddenly stopped working. So we had to solder it, and now it's working again. But those are all some minor flaws, which we have to account to.
Yeah.
But yeah, this is our base for now, and this is what we're going to rely on for the coming project.
This is, for example, the part which calculates by the wheel encoder the odometry. So this is C++. It's a node for us. We are subscribing on the wheel encoder again. Then we can do the wheel callback. And the wheel callback is calculating what was my previous left and right encoder and what is my changing. So you can detect which movement you made and what's your current location. So this part is calculate all those things and gives the good location where you are based on the encoders. So this is a piece of code which creates a new node. This is another example where you can control. There was a first test, for example. You just create a new z value and then publish it. So for now, go with a speed of 0.5 and do it for 3 seconds. So go 3 seconds forward. So like this. This is logic, but again, not on the Arduino, but in C++. So.
Do you want to rely on only the ticks of the motor shield, or is the...
That's a good question. Because for now we have to see if it's accurate. But again, then we have to view if it's the third part of our project, the location system. But we have to see if the odometry is accurate enough. Maybe we have to don't look about the location system. But then again, shoot Wi-Fi, GPS, something like, what do you call it? Beacons. Maybe should it be more accurate than the wheel encoder? So So we have to do research on that if the location system are needed, and
Mhm.
then which one we are going to use.
Okay. So I can imagine that you just have some less specific or less specific other location system.
Mm-hmm.
So when the robot is driving around and if it sees some NFC tag or something,
Mm-hmm.
that it checks if the location
Yes.
of the NFC check is the same
Yeah.
as the server thinks.
Something like that. Yeah, we have to do research about it because not every location system is that accurate. Like beacons is accurate for I thought 2 meters. GPS I think about 10-20 meters. So yeah, maybe odometry is just the most accurate one.
It might
Yeah.
be, but
That's- yeah.
if it's just a little bit off,
Yeah. It goes
it
fast.
doesn't matter the first hour probably, but after a day or 2 days or a week,
Yeah.
it might be off a lot.
Yeah.
And we have to look into that because the wheelchair has to be able to drive to work on multiple locations, so that means indoor and outdoor.
Yeah.
We set our goal, our product owner set the goal that it has to drive here in the T lobby.
Mm-hmm.
So, you know, our location system has to work indoor. So GPS practically falls off.
Yeah.
So yeah, but the wheel encoders were already there when we started or when we picked up the project. So we are using it right now because we already had it in our life.
Yeah.
So, and we thought it was a good case.
Okay. Maybe we should use the X1 because that's where innovation is.
Yes.
True, that would be a good test as well, but I think if it succeeds on the T lobby, it will also succeed on the X lobby.
Yeah.
Maybe it's then cheaper or easier to just place a physical tag like an NFC chip
Yeah.
on the floor.
That was
And,
my.
and if it drives over the tag, it knows, oh, here's this position again, and it
Yeah.
resets the position.
Yeah. Or checks if
Good
it's
point.
still correct. Yeah.
Good point. Also because NFC tags are very cheap. And yeah, it's a very good. It's a very good one. But you have to think also about the city when it's must do it in the city. You have to place through the whole city NFC tags, and those one are moving and yeah, a lot of research. Other questions?
Any more?